Today we're on page 6 of our chapter 5 notes, section 5, for the complex numbers. We'll actually be looking at imaginary numbers today. Let's look at the three quadratic equations at the top of our notes packet here on page 6. We're asked to solve x squared minus 4 equals 0. Well, we add 4 to both sides and we get x squared equals 4. Then take the square root of both sides, so x equals plus or minus 2. Those are two real rational roots. The next one, x squared minus 3 equals 0. Add 3 to both sides, x squared equals 3. Square root both sides, x equals plus or minus the square root of 3. Two real but irrational and unequal roots. And the third one, x squared plus 1 equals 0. Subtract 1 from both sides, and x squared equals negative 1. And then take the square root of both sides, x equals plus or minus the square root of negative 1. Well, we know that the square root of a negative number is not real. It's imaginary. Okay, so mathematicians didn't stop there. They let I, lowercase I, represent the square root of negative 1. So we use lowercase I to represent the square root of negative 1. By definition, a pure imaginary number is any number that can be expressed in the form bi, where b is a real number, but b doesn't equal 0. And I is the imaginary unit, the square root of negative 1. We want to express the following in terms of I and simplify. Number 1, we have the square root of negative 4. Well, this negative comes out as I, so this is I times the square root of 4. And now we can simplify the square root of 4, that's 2, so simply 2i. Next, number 2, the square root of negative 12. Again, the negative underneath the square root comes out as I. And 12 we'll express as 4 times 3. And the square root of 4 is 2. So the result here is 2i square root of 3. Number 3. Negative 2 times the square root of negative 45. The negative underneath the square root comes out as I, so negative 2i. Square root of 45 we'll express as 9 times 5, and the square root of 9 is 3. So it's 3 times negative 2i square root of 5, or simply negative 6i square root of 5. Always remember that I is equivalent to the square root of negative 1. We're going to be looking at powers of I. Note the most important power of I to remember is I squared. I squared is going to equal negative 1. I to the 0. Well, anything to the 0 power is 1. I to the first is I squared. Now remember, I is equivalent to the square root of negative 1, so if we take the square root of negative 1 and square it, squaring a square root removes the square root symbol. So this would actually be equal to negative 1. Next, I cubed. I cubed can be expressed as I squared times I. And I squared is equivalent to negative 1, and negative 1 times I is negative I. It's important that you know these four. I to the 0 is 1, I to the first is I squared equals negative 1, and I cubed is equal to negative I. And this pattern continues. I to the fourth, I squared times I squared, negative 1 times negative 1 is going to be 1. I to the fifth, that would be 1 times I, that's I. I to the sixth is negative I. I to the seventh is negative I. Sorry, I to the sixth was negative 1. Apologize, wrote that wrong and said it wrong incorrectly. I to the eighth is 1. I to the ninth is I to the 10th is negative 1, I to the 11th is negative I to the 12th is 1, I to the 13th, you can guess, is I I to the 14th, negative 1, and I to the 15th is negative I. And it continues in this pattern. To simplify a higher power of I, you divide the power by 4 and note the remainder. Again, it's important that you know the first 4. That I to the 0 is equivalent to 1. I to the first is I squared is equivalent to negative 1, and I to the third is equal to negative I. So when we're faced with I to the 22nd, you divide the power by 4, so we would take 22 and divide it by 4 and note the remainder. So actually, if we go back to grade school and think of it this way, 4 divides into 22 5 times, it's 20, with a remainder of 2. Remember writing that capital R for remainder and then 2. Now write I to remainder. So I to the 22nd is equal to I to the second. And now write it as its equivalent. Well, I to the second, I squared is equal to negative 1. I'm going to stay here. I to the 23rd. Take that high power of I, 23, divide it by 4. 4 goes into 23. 5 times is 20. Subtract. Our remainder is 3. So we write I to the 23rd as I to the remainder of 3. And now I to the third from above is equal to negative I. Next, I to 101. We're taking 101 and dividing it by 4. 4 goes into 101. 4 goes into 125 times. It's 100. Subtract, and your remainder is 1. So we express I to 101 as I to the first, which is simply I. I to the 32nd. Take 32, divide it by 4. 4 goes into 32 8 times. It's 32 with a remainder of 0. So I to the 32nd is equivalent to I to the 0. Anything to the 0 power is 1. So that's equal to 1. Next, I to the 49th. Take 49, divide it by 4. 4 goes into 49. 12 times is 48. Subtract, the remainder is 1. So that's equivalent to I to the first, which is I. Next, I to the 17th. Again, 17 divided by 4 goes in 4 times is 16. Remainder of 1. So that's equivalent to I to the first, which is I. Going on to page 7. Operations on imaginary numbers. Express in terms of I first. Take the negative out of the radical, put I as the coefficient, and then perform the operations and simplify. Okay, so we have the square root of negative 25 plus the square root of negative 81. That comes out. This is going to be 5i plus 9i, which is equal to 14i. Number 2, 5 square root of negative 2. The only thing you can simplify here is that the I comes out. So 5i square root of 2 minus square root of negative 32. The negative comes out as I, and the square root of 32 will express as 16 times 2 is 32, and the square root of 16 is 4. So this would be 4i square root of 2 subtracted from 5i square root of 2. And that leaves us with 1i, or simply I square root of 2. Number 3, square root of negative 12. Negative comes out as I, so this would be 2i over 5 The square root of 12 we'll express as 4 times 3. And the square root of 4 is 2, so 2 comes out, times 2i is 4i. So we have 4i square root of 3 over 5 times, simplifying, the square root of negative 75, I square root of 25 times 3, and the square root of 25 is 5, so this is 5i square root of 3. And we have multiplication, and before we go and multiply, the 5 in the denominator will divide out with the 5 in the numerator here. So it looks like we're left with 4i times I, which is 4i squared. The square root of 3 times the square root of 3 is simply going to be 3. And I squared is equivalent to negative 1. So this is 4 times negative 1 times 3, which is negative 12. And number 4, we have some division here. Again, expressed in terms of I first. So we have negative 5i, the square root of 80, that's 16 times 5 is 80. Square root of 16 is 4, 4 times 5 is 20, so negative 20i square root of 5. And our denominator, negative comes out as I, and 45 would be 9 times 5. Square root of 9 is 3. 3 times 2 is 6. 6i square root of 5. Square root of 5's divide out. The i's divide out. And the negative 20 and the 6 dividing by 2, we have 3 and negative 10. So this is equivalent to negative 10/3. All right, we'll have more practice with this in class. And the last thing for today is looking at our complex numbers on a coordinate plane. All right. A complex number is any number that can be expressed in the form a plus bi, where a and b are real numbers and I is the imaginary unit. We want to graph the following. We want to graph negative 8 plus 4i. So we want to graph the complex number that has a real number part of negative 8 and an imaginary part of 4i. Well, our x-axis remains our real number axis, and our y changes to our imaginary. So if we want to graph negative 8 plus 4i, we go to negative 8 on our x-axis, and then up to 4i on our y-axis. So that would be this point right here, negative 8 plus 4i. Next, number 2, 7 plus 9i. 7 is a real number part, 7 on the x-axis, and up to 9i on the y. 7 plus 9i. Number 3, 6 minus 5i. Positive 6 on the x, negative 5i on the y, places us right here, 6 minus 5i. Try the next 4, pause the video, try the next 4 if you like. Negative 9 minus 7i, negative 9 real number part, negative 7i imaginary. Zero plus 2i, that would be 0 on the x-axis, and then up to positive 2i on the y. 5 plus 0i would be just the real number 5. Number 7, 0 minus 6i. So 0, real number part, and then down to negative 6i. Okay, and this concludes our lesson for tonight.